So we've already been talking about writing linear equations in something we call slope-intercept form. Now we're going to do point-slope form, so taking those same linear equations, writing them a different way. So again, we've learned how to write an equation of a line by using its y-intercept. That was the intercept part of slope-intercept form. In this lesson, we'll learn how to write an equation without using that y-intercept, which allows you to use more different kinds of situations as a start. You can use the slope of a line at any point on that line to write and graph an equation of the line. So any two equations for the same line are again going to be equivalent. And the point-slope form that we're going to use of an equation with slope m going through point x1, y1 is y minus y1 equals m x minus x1. And it's always going to follow that pattern, and you're really only looking to plug in two certain things. You're looking to plug in the slope of the line that you're going to use, and since you also have a point that starts on that line, you're going to plug in the point in two different places, the x-coordinate with x1, and you're plugging in the coordinate for y with y1. So if I try to use that graph, again, your slope is still rise over run, so slope is going to be m. And when I use that equation for point-slope form, again, x1, y1, if I use a subscript, is referring to a specific point that's on that line. So if I look to my first example with point-slope, if a line is going through 8, negative 4, and has a slope of 2/3, we want to use those two pieces of information to write an equation in point-slope form. So point-slope form, I have my point, I have my slope. All I want to do is plug those parts into the formula. So I wrote that formula again. So this is your point-slope form just in any general form. But if I know that the slope is 2/3, I'm going to plug that into my formula. So it just gets plugged in outside of my parentheses. And if I know that the line also passes through 8, negative 4, that's my x and my y coordinates. So if I'm going to plug 8 in for x1, I have an x minus 8. And if I plug in negative 4 for y1, what you see here, and most common mistake I think with this form, is that we have to remember that since in your formula we're subtracting your coordinates, it's going to look kind of like the opposite of what your coordinate looks like. So if the x was positive 8, in the formula it's going to look like x minus 8. And on your point, negative 4 for the y, it's going to be minus a negative, so that's y plus 4. So again, we just take that formula, we're plugging in a slope of 2/3, x coordinate is 8, y coordinate is negative 4. Just make sure we simplify and write that in our point slope form. So if I also want to go another way and graph a line based on my equation, I know that I have y plus 7 equals negative 4/5 and the quantity x minus 4. So I still have those same two pieces from earlier. I still have a slope, negative 4/5, and I still have an x coordinate and a y coordinate. We just have to remember that since it's x minus x1, your x coordinate's not negative 4, it's a positive 4. And again, since it's minus, y plus 7 means it would be the opposite, minus negative 7. So your coordinate is at 4, negative 7. If we want to graph that, I can start by graphing the point. So if I know that 4 and negative 7 is a point on the graph, I'm going over here for an x coordinate of 4 and a y coordinate of negative 7, so I know this point is on my graph. And then if I know the slope is negative 4/5, I just have to remember that this is rise over run. So rise is negative 4, I go downwards 1, 2, 3, 4, and if the run is 5, I go 1, 2, 3, 4, 5 spaces to the right. So if I start with my point and follow my correct slope, that should allow me to put another point on my graph, and then I can just connect those using a straight line. So I just start with a point, follow the slope, and then connect a line. So trying that a bit more, we can write the equation of any line if I'm given 2 points on the line. So last time we had the slope and 1 point, but I could also just use 2 points. So first we're going to use the two given points to find the slope, and then we're going to do the same thing as what we did before. We're going to use the slope and one of those points to write the equation. So if I start with a question like this instead of on the last page it told me what the slope was, but this time I just have to find that myself. If one of my points is 1, 4, and another point on the line is negative 2, negative 3, again, your slope formula is just where you're taking the y's and subtracting them. So to find your slope, the formula is y2 minus y1, so negative 3 minus 4. Remember, you can also switch those two, so 4 minus negative 3 would also work. And then you just want to use that same x coordinate, so negative 2 minus 1 is x2 minus x1. If I simplify that and it's negative 7 over negative 3, I just remember that the negatives cancel, so that slope in simplest form is 7/3. So in my equation, remember slope just gets plugged in outside of your parentheses, so in the formula I plug in my slope for m, and as far as the point, I have a choice really. I could plug in the first point, so x minus 1 and y minus 4 if I plug in the first coordinate, or if I plug in the second coordinate, I could also make the same equation, but just replace that with x plus 2, so remember that's minus a negative, and also y plus 3. So just remembering that it's the opposites, I could use either of those points to make my equation. And now if I rewrite that equation that we found earlier, we can see that we can also make those same equations in slope-intercept form. And we don't have to worry about comparing the two. But if I took the equation from what we started with, so y minus 4 equals 7/3 x minus 1, if I want to go back and forth from one to the other, I could just distribute the 7/3. So I'm multiplying it times x. I'm also multiplying it times negative 1. I get 7/3 x minus 7/3. And then for slope-intercept form, remember that's your y equals mx plus b form. So if I want to isolate the y, I can add 4 to both sides. I just did some side work here to say that I could take 4 and add a negative 7/3, and that would get me 5/3, and that gives me my equation. Again, I just start with the point slope form, distribute so that I'd have the 7/3 x as my slope, and then if I just isolate by adding 4, then I have an equation that has y on one side. And now I have my slope and y-intercept. So if I put this into a word problem, I can also solve questions like this. A table shows the number of gallons of water y that's in a tank after x certain amount of hours. And if we're told that the relationship's linear, that means we should be able to make an equation in point slope form that models it. So first thing that we're looking at is I have 2 points that you could choose. Could be different from what I chose, but I chose one coordinate would be x is 2 and the y is 3,320. And my second point that I chose, again, could be different for yours. My x is 3 and the y coordinate there would be 4570. So first thing we're doing, just like the last problem, I want to find the slope between those 2 points. So I subtract the y's. 4570 minus 3320 is 1250. And subtract the x's on the bottom. 3 minus 2 is just 1. So if I use that to find my slope is 1250. I plug that in, same place in the formula, goes outside my parentheses. And that just means for the last part of my equation, I just got to choose one of these points to plug in. Could be either one, but I chose the first one, so x minus x1 is x minus 2. And if I want to subtract y1, that's minus 3320. So it also asks us what the slope represents in this case. And the slope here, especially if you use units when you're finding the slope, the units for the y's was gallons, the units for the x's was hours. So if I think about this in terms of gallons per hour, that's talking about the speed in which that tank's being filled. So a certain amount of gallons covered every hour that you're filling that tank. So now if we want to do the same thing as what we did earlier and rewrite that in slope-intercept form, remember slope-intercept is your y equals mx plus b form, we're going to follow our same steps. So I distribute just like the last time. I multiply 1250 times x, 1215 times negative 2. And since in our slope-intercept form I want the y to be isolated, I have to add to cancel out my negative 3320. And if I add that to both sides, I get this equation, 1250x plus this should be 820. So that tells me what my slope should still be the same. Y-intercept would be 820. And in this situation, what we're talking about for y-intercept, remember, that's what happens when your x is 0. So at 0 hours, we had 820 for gallons. 0 hours just means we haven't started filling it yet. So in this situation, the y-intercept is going to represent the amount of water that we had in that tank before we started filling it. So when time was 0. So we can just finish with that. We'll get the rest of these notes covered in class, and be sure to come in with any questions that you have.